Stability AI has just unveiled the world's latest open-source masterpiece, Stable Video Diffusion. This AI video model is based on the renowned Stable Diffusion image model and is already vastly outperforming industry giants like Runway ML and Google's Pika Labs. So let's take a detailed dive into Stable Video Diffusion, its benchmarks, and its future in this three-part overview of the next revolution in AI-powered video generation and more. Part 1. Introducing Stable Video Diffusion. Stability AI's latest model seamlessly converts images into captivating videos, but there's a twist because Stability AI has also introduced two distinct image-to-video models, each capable of generating videos with between 14 to 25 frames. This gives users the flexibility to customize their frame rates, ranging from a slow and detailed 3 frames per second to a swift and fluid 30 frames per second. Furthermore, the creation of Stable Video Diffusion was meticulously executed throughout 3 phases, starting with text-to-image pre-training. Next, this was followed by video pre-training using a comprehensive dataset of low-resolution videos. The final phase saw the model being fine-tuned with a more selective, high-resolution video dataset. This rigorous training process, underpinned by a high-quality video dataset, ensures that Stable Video Diffusion stands out in terms of both efficiency and efficacy. Part 2. Benchmarks. In an industry where performance is key, Stability AI's benchmark studies reveal that Stable Video Diffusion is the market leader in its comparisons with commercial counterparts like Runway ML and Pika Labs, with participants in these studies having rated the videos generated by Stable Video Diffusion higher in terms of visual quality and adherence to prompts. However, this achievement is not the endpoint because while Stability AI's model currently leads among available commercial models, it still faces stiff competition from Meta AI's new Emu Video, which has also shown even more impressive results. But it's important to mention that Emu Video is currently limited to research and demonstration purposes. Part 3. The future of AI video generation. Beyond the immediate successes, Stability AI's vision is to build a robust foundational model for video generation. The researchers have proposed innovative methods for curating vast amounts of video data, aiming to transform cluttered video collections into refined datasets suitable for AI training. This methodology is designed to streamline the process of developing generative video models, setting the stage for more advanced and efficient video creation tools. Moreover, Stability AI envisions the Stable Video Diffusion model as a versatile foundation for various downstream tasks. This includes multi-view synthesis from a single image, extending to multi-view datasets with fine-tuning. The company is committed to developing an ecosystem of models that build upon this foundational technology, akin to its successful strategy with Stable Diffusion. Currently available as a research version on GitHub, Stability AI is still keen on gathering insights and feedback regarding safety and quality. This cautious approach aims to refine the model for its final release, ensuring it meets the high standards set by the company. Plus, it's important to note that this version is not intended for real-world or commercial use, but once it has been fully released, like its predecessor Stable Diffusion, the model will be freely available to the public as an open-source alternative to AI video generation. In addition to the technological advancements in video generation, Stability AI is simultaneously making strides in other AI domains too. For instance, they've recently released open-source models for 3D generation, audio generation, and text generation using their large language model architecture, with these developments being a testament to the company's commitment to pushing the boundaries of open-source AI implementations. Overall, as Stability AI prepares to continue its journey with the upcoming text-to-video interface, it opens new avenues in advertising, education, and entertainment, with these new tools providing users with intuitive and practical applications to use the technology for free. Additionally, Stable Video Diffusion has also been integrated into Comfy UI, which is a user-friendly graphical interface for Stable Diffusion that opens up new possibilities for private users. Plus, Comfy UI's Graph and Node interface facilitates the creation of complex workflows, offering an intuitive and efficient way to leverage the capabilities of Stable Video Diffusion. This update makes it possible for users to generate high-resolution videos at a 1024 by 576 pixel resolution, at a length of 25 frames, even on older hardware like the NVIDIA's GTX 1080 GPU. But the update's compatibility extends beyond NVIDIA GPUs to access other platforms too, with AMD users also being able to harness the power of stable video diffusion on an AMD 6800 XT running Linux, for instance. The ability to create a video in approximately 3 minutes showcases the efficiency and accessibility of SVD, making advanced video generation achievable for an even broader range of users. Finally, to further assist users, the developers have published 2 sample workflows for stable video diffusion in Comfy UI, catering to both the 14-frame and 25-frame models, with these samples serving as guides and inspiration to help users to explore the full potential of the tool while encouraging creative experimentation. Meanwhile, MetaApp AI Research and its collaborative team from several Chinese universities have unveiled MetaDreamer, an advanced tool poised to transform the creation of 3D models from text descriptions. MetaDreamer stands out as the fastest system to date in this domain, marking a significant leap in the field of AI-driven 3D modeling. MetaDreamer operates through a novel 2-stage process that addresses common issues in 3D model generation. The initial geometry phase focuses on shaping the 3D object to ensure its accuracy from various angles. Following this, the texture phase adds detailed textures, enhancing the model's realism. This bifurcated approach ensures the models are both geometrically sound and visually appealing. The tool's efficiency is remarkable, with MetaDreamer being able to generate detailed 3D objects from text descriptions in just 20 minutes, utilizing the power of a single NVIDIA A100 GPU. This speed is unmatched in the current field, showcasing MetaDreamer's potential as a trailblazer in rapid 3D modeling. MetaDreamer's capabilities were rigorously tested against existing text-to-3D methods like DreamFusion and Magic 3D. The results were clear. MetaDreamer excelled in speed, quality, and its ability to closely match text descriptions. It also secured the highest score in the T3 benchmarks, further cementing its position as a leading tool in 3D model generation. Despite its achievements, though, MetaDreamer is not without limitations. Currently, the tool faces challenges in creating scenes with multiple objects, a hurdle the team is actively working to overcome. Future improvements aim to enhance the model's understanding of object interactions in 3D space, promising even more sophisticated and intricate model generation. Overall, MetaDreamer represents a significant advancement in the realm of generative AI for 3D models, with its rapid processing time and high-quality output positioning it as a key player in the industry.